As promised, we're back with grade 12 trigonometry. This is one of those really big topics that makes grade 12s a little bit scared. So I just want to go through the basics of the identities that you need to know for your grade 12 trigonometry. So by now you will know that you have 4 compound angle identities. And we need to be able to derive 3 of these 4 compound angle identities, but we'll keep those derivations as a separate video. I've advised that you must be able to work forwards and backwards with these identities. So don't just rely on your formula sheet. Make sure that you can actually recognize the sine, cos, sine, or the cos, sine, sine. Okay. Then we went on to the double angle identities, and these are all derived from your compound angle identity. So again, the derivations are something that you need to know, but it's something that we'll come back to later. Your sine double angle has only one identity, but what I do recommend to my students is that you give a variation of this identity by dividing both sides by 2. So that 2, if we divide by 2, we get a half sine double angle is equal to sine angle cos angle. All right, there's a nice space on your formula sheet where you can actually write this right next to the sine double angle. Your cos double angle, you have 3 options, and this is going to be probably one of the biggest challenges for you, is to decide which of these 3 you're going to pick depending on what the question looks like. Okay, so I've got a couple of really little basic problems over here just to get you used to the identities. The first one, if you look at it, it looks a little bit like this one, 1 minus 2 sine squared alpha. The problem is we're sitting with a half and a 1 instead of a 1 and a 2. So all I did here was I said, how about we take out a half as a common factor? Remember, a half goes into any whole number. So I took out a half as a common factor. That left me with 1 minus 2 sine squared, 22,5. And I said, that is a double angle. And so it's a half cos double 45. Double 22,5, which is 45, and that is a half cos 45, which ends up being root 2 over 4. Okay, cos 45 is either root 2 over 2 or 1 over root 2, and whichever way you work it out, that's your answer. All right, the second one, just to reinforce what I told you about the sine double angle, if they say simplify this without using a calculator, you're going to say it looks like the 2 sine alpha cos alpha, but the 2 is missing. So we're going to use the half sine double angle. And so it's a half sine double 15, which is a half sine 30, which is a half times a half, and therefore the answer is a quarter. Okay, so you're going to have your wits about you just a little bit when you start working with these grade 12 identities. Let's have a look at these 3. These are still fairly average level questions. The first one, let's call that 1A. The first one looks a bit strange because you've just got a cos 15 and a sine 15, and then you've got numbers that look a bit like the results from your special angles. So if I were to say a half is either cos of 60 or sine of 30, then I would have, let's say, sine of 30. So it'll be sine 30 cos 15. And then root 3 over 2 is actually cos 30. And so as long as we choose the same angle for both, in A, we're going to say it's equal to sine 30 cos 15 plus cos 30 sine 15. And hopefully you now recognize that as a compound angle identity. It's our sine plus for sine. And so it's sine of 45 degrees, which is root 2 over 2 or 1 over root 2. Okay, so watch out for those. They can hide them or disguise them a little bit more cleverly, but every time you'll be able to turn it into a compound angle identity. Okay, the second one we don't have to do because we've actually just spoken about it. So we're going to jump over that one. The third one, this technique is going to stand you in good stead as you do your grade 12 trigonometry. If it's a binomial squared, remember that what we're actually going to do is we're going to write the binomial out twice. If you're very good at squaring, then go ahead by all means and use the shortcut. So it's going to be sine squared 15. Then my outers and my inners are the same. So that's going to end up being minus 2 sine 15 cos 15. My last, a minus times a minus is a plus cos squared 15. And that makes me really happy because these two, if I were to put them together, do you remember in grade 11, sine squared plus cos squared is 1. And so that gives me 1. And then this is my sine double angle. And so the whole question comes down to 1 minus sine of 30, which is 1 minus a half, which is a half. Okay, so those are your numerical style questions. So what if we go and look rather at our more proof type examples? So we've got to prove that over here. Prove that very complicated left-hand side is equal to fairly simple looking right-hand side. Okay, be really careful when you write out a question that says prove that. Okay, you can't just go and copy down the question and say that is equal to that, because then you're pretty much saying they're equal. Why must I bother to do anything else? So be careful to do your left-hand side. And by all means, you can put down your right-hand side. And maybe you even want to think about your right-hand side as sine theta over cos theta, just because that helps you to focus on what you're going to choose for the left-hand side. Okay, so on my left-hand side, the sine 2 thetas are not difficult to decide what to do with because we only have one choice. The cos 2 thetas are the problem. We can't work with 2 thetas on the left and single thetas on the right. So the 2 thetas have to be expanded. So what I'm going to do at the top in my numerator, I'm going to say, I don't want this 1. This 1 is making everything messier. So I'm going to pick the option for cos 2 theta, which will help me to get rid of the 1. In other words, I want a positive 1 in the bracket. And so I'm going to pick the 1 minus 2 sine squared theta. And then obviously I've got to expand this guy to sine theta cos theta. Okay, before this gets too messy, let's just draw a line. In my denominator, I have a similar but opposite problem because now there's a plus in front of the cos 2 theta. So now I'm going to pick the 2 cos squared theta minus 1 option because then I've got a 1 minus 1. Okay, and then this will be the same. All right, so now we should be quite pleased with ourselves because 1 minus 1 will mean that the 1's add up to 0. Minus a minus makes that a positive 2 sine squared theta plus 2 sine theta cos theta. At the bottom, the cos squared is plus, but the 1 minus 1 makes 0, and so I'm left with something similar. Right, the worst thing you can do now is to start cancelling anything because we have a plus and a plus. Okay, so what we're going to do is we're now going to use all our other mathematical knowledge like we did in grade 11, and we're going to factorize. So I'm going to factorize the numerator by taking out a common factor of 2 sine theta. And I'm going to factorize the denominator by taking out 2 cos theta. And now I'm very, very happy with myself because 2's divide, the brackets divide. Remember, they're the same because with the plus, it's commutative property. You can switch them around. So I'm left with sine theta over cos theta, which is exactly what I wanted. There, I can see it. And so I can conclude that the left-hand side is equal to the right-hand side. Right, so that was quite a nice identity question. Next up. Oh, I had to sneak this one in because we've done sequences already. And so now we've got this little trig-looking geometric sequence over here. It says find a value for x, so we don't have to go to town here. But it's a geometric sequence. And the principle that we learned in a geometric sequence is term 2 divided by term 1 is equal to term 3 divided by term 2. And it's that property that I'm going to work with now. So that is term 1, term 2, term 3. And now it becomes a lot less threatening because I'm going to have root 3 sine x over sine x is equal to sine x over cos x. Okay, I've written them back to front, but it really makes no difference. Sine x is divide out. This is tan x. And so we've ended up with tan x is equal to root 3. And we only need one angle. So we're going to do the shift tan of root 3 to give us a value for x. It is a special angle, so technically we're supposed to know it, but there's no harm in checking. So x is 60 degrees. And we are happy. Right, the next identity looks very scary. It just looks scary because it's so big. Clearly, we have to work with the left-hand side because the right-hand side is already a numerical value. Okay, so it could be a prove that, or it could be an evaluate style question. So I have to focus on the left And I'm likely to focus on my double angles. And I'm also going to focus on numerical angles that are bigger than 180. Okay, so I'm not going to mess much with the top at the moment. I'm going to leave the numerator just as it is. Cos 2a, I'm not 100% sure what I want to do with it yet. So I'm going to leave it as cos 2a. And I'm not allowed to use a calculator, although it didn't say so. So I'm not going to touch the sine 15. At the bottom, I'm definitely going to expand the sine 2a. And that just makes me feel happy when I see what the numerator and the denominator are doing. In the bracket, tan of 225 is in the third quadrant. Tan is positive in the third quadrant, so it's a 180 plus 45. Unfortunately, we do have to write that step in. Otherwise, we're going to be accused of using our calculators if we're not supposed to be using a calculator. All right, so if you want to, you can already say those divide out because they're factors. 2 goes into 4 twice. So in the numerator, I've got 2 cos 2a sine 15. In my denominator, tan of 45 is 1. And that makes me really happy again because that is a cos double angle identity. So I did the right thing by not messing with that cos 2a. Because at the bottom, it's also cos 2a. So the cos 2a's divide out, and we left with 2 sine 15. I'm still not allowed to use my calculator, so I've got to bring in another clever step here, and I'm going to change that 15 into 45 minus 30. I could just as well have used 60 minus 45. So I now have 2 sine 45 cos 30 minus cos 45 sine 30 root 2 over 2 root 3 over 2 and root 2 over 2 times 1 over 2. Okay, nearly there. Let's keep that 2 out for now. Root 2 times root 3 is root 6, if you remember your grade 11 surd rules. And that becomes root 2 over 4. And then our final step, we can say this 2 outside multiplies to each of these, and it simplifies to root 6 over 2 minus root 2 over 2, which is exactly what the right-hand side was. There we go. All right, so there was quite a lot of work involved there. In fact, all the tricks in one question, but it wasn't, in the end, mathematically very difficult. You just had to be brave and you had to keep pushing through. Okay, we're going to do one more in this video, and then we'll put the other examples into a new video so it doesn't get too long. I like this example because it's a warning that things could go horribly wrong if you make the wrong choice. So be careful about zooming in too quickly and not looking at the whole question. If you zoom in too quickly, you're going to see this as a compound angle, and you're going to want to start expanding it, cos, cos plus sine, sine. If you do that, you're going to end up with two really monstrous terms over here. And then you're going to have to do the same thing on this side. And so you're going to end up with four really monstrous terms. If, however, you zoom out for a minute and you look for patterns, you notice that the angles are the same. And so it becomes a cos alpha cos beta sine alpha sine beta, which is a much nicer approach for this question. And so we don't actually have a left-hand side, right-hand side here. And so this is your cos compound angle. And with cos, whatever sign you have in the middle over here, it changes. So it becomes a plus x. Okay, so there's your first angle, then your plus, and then your second angle. In the denominator, 205 is third quadrant. So that's a 180 plus, but it's sine, so it's negative sine 25 cos 25. Right, so my numerator is now fantastic because minus x and plus x will subtract out to make 0. And so my numerator is cos 40 degrees. My denominator is a little bit interesting because it's that sine cos without the 2 again. So we're going to make it a half sine double 25. All right, and now you should be very pleased with yourself if you've got this far, because now you've noticed that 40 and 50 are co-functions or co-ratios. And so I'm going to change the numerator to sine 50, the bottom minus a half sine 50. The sine 50s divide out with each other, and I'm left with 1 divided by negative a half. Okay. And hopefully you know that when you're dividing by a fraction, you tip and times, invert and multiply. And so your answer is negative 2. All right, so that gets us a little bit into the trig identities. I have some nice challenging ones to come, but I think we're going to put that into our next video. So that's all for now.